You have learned about displacement, velocity, and acceleration when you were in grade 7 and 8.
Velocity, which is a change in position per unit time. Average velocity, which has the same definition for any average. And acceleration, which is the change in velocity per unit time.
Using these equations, we can derive other equations.
To find out how displacement changes with time when an object is uniformly accelerated, rearrange equation A to arrive at d is equal to v times t. Since the velocity of the object changes when it is uniformly accelerating, we can use the average velocity to determine displacement. So, substituting v by v average in equation B, you will get d is equal to the quantity v sub f plus v sub I divided by 2 times t. And we will label this as equation D. Rearrange equation C to arrive at v sub f is equal to v sub I plus a times t. And substituting the v sub f in equation D, we will get d is equal to the quantity v sub I plus a times t plus v sub I all over 2 times t. Combining v sub I, we will arrive at d is equal to the quantity 2 v sub I plus at divided by 2 times t. Distributing t will give us d is equal to 2 v sub I t plus a t squared divided by 2. Simplifying further will provide us d is equal to v sub I t plus 1/2 a t squared. And this is our equation E.
This shows that the displacement of the body is directly proportional to the square of time. This confirms that for equal interval of time, displacement increases quadratically.
Now to find out how final velocity depends on the displacement, substitute v and t from equation B and C to d is equal to vt, which is our equation A, and we will find that d is equal to the quantity v sub f plus v sub I over 2 times v sub f minus v sub I over A. Recall from your algebra class about special products that the product of the sum and difference of two terms is the difference of the squares of the terms. So, d is equal to v sub f squared minus v sub I squared divided by 2a. Simplifying, we will get 2ad is equal to v sub f squared minus v sub I squared. Rearranging, we will get v sub f squared is equal to v sub I squared plus 2ad. And this is our equation F.
These formulas are the fundamental kinematic equations we use in solving UAM. These simple equations govern the motion of all objects in 1 and 2 dimensions.